Question 31. Electronics and Communication Engineering, GATE 2015 Set 2. In the circuit shown, the Norton equivalent resistance in ohm across terminals A and B is dash. For a detailed lecture on this concept, please refer the NPTEL video, Module 1, Lecture 10, Thevenin and Norton Theorem and Equivalent Circuits by Dr. Nagendra Krishnapura, IIT Madras. Let's understand Norton's theorem and then solve this problem. According to Norton's theorem, any complicated network can be replaced by a current source in parallel with an equivalent resistance. This current source is called as Norton's current, and the equivalent resistance in parallel to it is called as the Norton's resistance. And this circuit will be connected to a load in parallel. Let's apply this theorem and solve this problem. We are asked to find out the Norton equivalent resistance across the terminal A and B. Usually, we open circuit the current sources and short circuit the voltage sources to find out the equivalent resistance. But here we have a dependent voltage source. Therefore, we cannot simply short circuit it and say that the Norton's current is 4 parallel with 2 parallel with 2. Now, we have to apply a test voltage Vt and find out the ratio Vt divided by It, and Rn is equal to Vt divided by It. Let us label this node to be X, and the voltage at X is equal to Vx. By Kirchhoff's current law, we can say that all the incoming currents is equal to the outgoing currents. Here we have two incoming currents, one from this branch and the other one from this branch. There are two outgoing currents through this path. According to Kirchhoff's current law, It plus 4I minus Vx divided by 2 is equal to Vx divided by 2 plus Vx divided by 4, where I is equal to Vx divided by 4. Let's substitute the value of I over here. It plus 4 into Vx by 4 minus Vx divided by 2 is equal to Vx by 2 plus Vx by 4. This current goes to 0 because Vx minus Vx is 0. So this is also Vx and this is also Vx. Therefore, this current, let us call it as Ia, this is equal to 0 because when there is no potential difference, no current flows into that branch. This implies that It is equal to 3Vx divided by 4. Now we can understand that Vx is nothing but the applied voltage Vt. So It is equal to 3 by 4 Vt, and therefore the Norton equivalent resistance is equal to Vt divided by It, which is equal to 4 divided by 3, which is 1.33 ohm. The Norton equivalent resistance across the terminals A and B is 1.33 ohm.